Welcome to the Carbonsations podcast, where we speak to some of the leading figures in the emerging carbon industry. Our guest today is Claude Letourneau, President and CEO of carbon capture and removal provider Svante. Claude, thank you so much for being on the show today. We have a tradition on this podcast where we get to know our guests a little bit better before diving into the carbon side of things, particularly because this sector is still so young and nobody was born into it, so to speak. So please do share a bit of your backstory and what you used to do before Svante.
Well, thank you for the invitation. I'm very pleased to be here. So I'm a chemical engineer by training, and I spent all my career on two aspects of the innovation value chain. So did a few startups in early my career. One of them was to make the first ever lithium polymer batteries for electric vehicles. So we developed a thin film technology that allowed basically to have a complete battery pack made of lithium batteries in the mid-1990s. I then moved on to other ventures like doing membrane separation for ethanol in the biofuel era, and went back to working for a large company. A company was called SNC-Lavalin. So we were doing engineering construction projects around the world in deploying very large infrastructure in the mining and metallurgical sector. So I understand what it takes to take something out of the lab and bring it to a new industry, at the same time deployed massively at scale, big industrial facilities.
Thank you. Now, moving on to Svante's work, I know the company is quite rare in what it does because you guys provide both carbon capture as well as carbon removal solutions. Could you please explain in more detail how you can do both and what exactly the company's business model is?
Yeah, absolutely. Well, Svante, first of all, was named after a scientist 135 years ago, Svante Arrhenius, who was one of the first scientists to make the correlation between CO2 going out in the atmosphere and the temperature of Earth going up. So Nobel Prize as well. So we named the company because we felt it was one of the grandfather of the climate problem that we're trying to fix here. So 135 years problem, we're trying to find a solution to. So the approach we take is one very different from the oil and gas industry who's been using a very conventional technology called gas to liquid. And that's what they use to separate different gases and when they basically refine the oil and gas. But in our case, we took the technology of what I referred to earlier as the solid state lithium batteries and apply a solid state approach to resolving the problem of capturing CO2 from very diluted stream. So either from the air or from a diluted stream from a cement factory or a steel factory where you may have 14 to 50% CO2. So we do carbon capture and removal using solid sorbent filters. So we coat this nanomaterial that we've engineered, and that nanomaterial likes basically to CO2 versus the nitrogen you would find in post-combustion gases. And it allows basically to concentrate the CO2 to high concentration so that we can then move the CO2 for either storage or use it for utilization and reuse of the CO2.
Thank you. That's very fascinating. And I know that in the last few months, maybe a year even, Svante has made headlines with several very noticeable partnerships, including deals with Kiewit, Samsung Engineering, and TechDip Energies, to name a few. So I was wondering if you could comment on these partnerships and perhaps speak to their significance for the wider adoption of carbon capture technology.
Absolutely. So we have a unique business model in the carbon management value chain, where we focus on being an OEM, so an original equipment manufacturer, where we manufacture physically the filters to capture the CO2, both for air capture and for point source application. So we are building a factory as we speak to make these filters at large commercial scale. And we also wrap the equipment, which is the contactor that allows to regenerate these filters every 60 seconds. So we provide the equipment as well. And we're wrapping all of this with a process package from the low concentration all the way to compressed CO2. So the technology license comes with this as part of our OEM delivery. But in order to go to market, we decided to have a very strong partnership approach. And so we have 3 platforms of partnership. The first one is who in our industry can help us scale very quickly our OEM business. So we selected two companies. One is BASF, a very large chemical companies. And we went to them and says, do you want to scale up the nanomaterial that we call a MOF, which is a metallic organic framework, the sorbent, the magic powder, basically that goes into our filter. And they've basically scaled that up to large commercial scale, and they're now supplying it exclusively to us. So that's one partner. The second one is 3M, very famous for coating and post-it. And because we use a coating technology to put the sorbent on a roll, we work with them to develop basically the capacity specifically for the direct air capture, which requires much more volume of filters than the point source. So that's on one platform. The second platform is the channel to market. So how do we go and build these carbon capture plants? And we've elected to partner with only 3 engineering construction companies worldwide in order to be able to scale quickly and minimize having to reinvent the wheel all the time with new EPC partners. So we have Kiewit for North America. We have Technip Energy for Europe and Samsung Engineering for Middle East and Southeast Asia. And these 3 partners are basically our preferred partners to work with to be able to deploy our carbon capture turnkey facilities throughout the world. The last one is about partnering with the industry that's going to build basically the infrastructure to transport the CO2 effectively and be able to store the CO2 effectively. So what comes to mind is the oil and gas industry, because they have the knowledge base and the asset to be able to safely store the CO2. So many of the large energy players have been shareholders of our company and also partners so that we can develop these CO2 hubs and rely on them to basically provide a solution to either use the CO2 or convert or store the CO2 that we would capture with our customers. So 3 very distinct partnership platforms to do so.
So just to clarify, it's up to your customers to decide what and how they dispose of the CO2.
Of course, but very quickly when we get into discussing about a project, the source to sink discussion comes in play. And most of our customers are from the industrial sector. So obviously, some of them are from the energy sector, the oil and gas, who are trying to decarbonize their own industry by itself. So they're more sophisticated. They understand the transport and the storage aspect of it, and also the capture technology, because they've been capturing CO2 for a long time in their operation. But the industrial sector, they're very focused on the product they make. So making steel, making cement, making pulp and paper, they do not have necessarily the clear understanding of how to do these things. So they sort of rely on us to help them migrate to the various options of sourcing and sinking or finding a use for that CO2. So we get involved very quickly as sort of a partner to evaluate the project development and how to put this thing together. So there's a capture portion and then a utilization or transport and storage portion of it.
Okay, can you share a little bit more about specifically about like the transport and utilization? I know that you've partnered with Storega. So what options do you offer?
Yeah, so you've done your homework. So so those are also very selective project developer who have a business model of not only helping put together a project, but also they have asset for storing the CO2 themselves. So they're trying to get the expertise from the industry and basically leverage it to build different storage sites around the world. So we feel that Storega is basically one of the companies that has an international footprint in developing these things. So the idea is for them to become very familiar with the level of readiness for us to go to market, at what scale, what are the niche or the market segments in the industrial sector that our technology would fit better. So it's just basically eliminating the friction you would see in the interface between capture what we call the source and the sink and the storage aspect of it. So, but their business is to take the CO2 we would basically supply from our emitters relationship and be able to transport and store the CO2 safely.
Okay, and since you mentioned direct air capture earlier, there's one last partnership that I want to ask you about. It's with that company, Climeworks. As we know, Climeworks is among the pioneers in this sector. So what exactly does this collaboration entail?
Yeah, so many years ago, we felt that it was intriguing to think about direct air capture and the price point of doing it from the atmosphere. And then I sat down with our scientists and said, is there a way we can use our filter to do that? And because we've been focusing on more concentrated sources of 10% to 20% CO2. And the answer is yes. And I think it could be beneficial also to do it the way we do it versus the conventional way of just taking the sorbent, making beads, if you wish, and try to pack it and trying to force air through these pack bed. So we went to Climeworks, who was the leader and still one of the leader in that space, and basically says, well, give us your powder and then we'll convert this thing into a filter and you tell us if there's a capital cost and operating cost advantage. And after this relationship of 4 years, they came back and we've been testing it and now we're basically their supplier of what they call the Gen 3 technology that will basically be deployed at scale in the U.S. market with the first 1 million ton hub that they've been awarded to by the Department of Energy. And because we were scaling up our filter manufacturing plant for our own point source, we decided to basically work with them to custom design the modularity of making our filters so that we can use the same manufacturing line, same equipment to make either a filter for point source or a filter for direct air capture. So we are basically, if you wish, the filter inside or the intel inside the system that they are building. Very proud to be partner with them.
I also wanted to perhaps take a step back and look at the bigger picture of both carbon capture and carbon removal and get your opinion on how both these areas have been developing in recent years and perhaps what are some of the challenges that you're seeing now?
Yeah, absolutely. So let me do a fast forward and look at what that industry needs to be to have an impact on as a climate solution. So we emit roughly about 40,000 gigatons of CO2. About half of it is basically taken care of by nature through the photosynthesis and through ocean absorption. So there's about 20 gigaton that accumulates in the atmosphere every year. That's about 2.3 parts per million every year going up. So what we need to tackle as an industry is about 10 gigaton. 10 gigaton is 10,000 plants of 1 million ton. There is about 40 plants of 1 million ton today in operation, primarily in the energy sector, oil and gas sector. So we need to go from 40 plants of 1 million ton to 10,000 plants over the next 30 years. So that's daunting when you think about this. So we are trying basically to address the problem by having a scalable technology that can do these things. So 3 major, I would say, barrier were there, let's say, a few years back. So the first one is the technology available? And then people were saying technology is in the lab and not ready to be deployed commercial scale. Well, I think we've solved this problem. We cracked the code. We're ready to deploy at large commercial scale. We're building a factory as we speak that will be commissioned early next year that's going to do 10 plants a year of 1 million ton in filtering capacity. We need to get to 100 plants a year capacity, 2 a week, just to give you the idea of meeting the goal of 10,000 plants over 30 years. So technology is there, and there's other technology like solvent technology or cryogenic that are there as well. So there's a suite of technology available to address both the carbon capture and the carbon removal space. Not an issue anymore. Second, there's not enough storage capacity to store all the CO2. So the major energy companies, oil and gas primarily, and a few other early stage companies have basically put the effort of building with government support these CO2 hubs. So transport CO2 hubs are being built as we speak. I think these hubs will come in operation with probably a lag between the supply of CO2 to these hubs. So that's a good problem to have. The third one, which is the most difficult one to resolve now, is the monetization of CO2. Who pays to capture a waste material? Yes? So I think the example I can give you is that in our modern world, we spend about $1,500 per person to manage our domestic waste, which is about 700 kilograms of waste that we all individually generate every year. Now, the same amount of annual spending, about $1,500, basically, if you equal this to the 10 tons of CO2 we all individually are responsible with the carbon intensity of all the product we consume, well, take 1,500 divided by 10 tons of CO2 we're all responsible, that's $150 per ton. So the question asked now is it too expensive? The answer, no. If we can afford managing our rubbish through waste management, we can certainly afford the same amount of money to manage our CO2, and it's called the carbon management industry. Now, the question is that it was free to put it in the atmosphere. But now the social cost of CO2 emission, which is the impact it has on the climate, on water level, on fires, on all kinds of things related to what people refer to as climate changes, that social cost now has been set by the U.S. government lately at $190 per ton. And experts say it will reach about $300 per ton in the next decade. Now, if the social cost is in the $190 to $300 and your cost of capturing it is less than $150 per ton, then there's an incentive for people to do these things, yes? But not doing it, that's the cost of inaction, and it's going to be more expensive. So I think the monetization is basically an area that we spend a lot of time. Different countries, different locations have different industries have different ways of doing it. But, in reality, emitting carbon is like using a credit card. Sooner or later, we will have to pay for it, yes? So U.S. government decided to basically de-risk the buildup of the infrastructure that is required for the first time of building these pipelines, storage, and carbon capture. And they're providing a tax credit, which is basically $85 per ton to do this on an industrial level. So that gives us enough money to get a few of these projects going. But eventually you need to go to what we call a business-to-business relationship where there's a carbon pricing system in place that will spur the efficient carbon market so that you can generate the revenue from what we call the product carbon intensity along the supply chain. So if everyone from making a raw material that goes into making another material that goes into making the final product we all consume, steel, plastic, and all the like, and there's a carbon management done based on lowering the carbon intensity of every one of these products in the supply chain, then you have a way of eventually paying for the cost of capturing CO2. So we call this carbon smart. That's what we need to get to, and that's the mechanism that will allow us to have a price on carbon, so people can pay for a waste material that has limited value.
Since you touched on tax credits in the U.S., could you also speak to the kind of federal support for carbon capture that's available in Canada versus the kind that's available in the U.S.?
Yeah, Canada has a different approach, more closer to what you would find in Europe and other parts of the world. So we have what we call a carbon price. So there's a price on carbon. So emitters basically have to pay a price to the Canadian government that takes it and reinvest it basically in carbon reduction initiatives. And in doing it, the Canadian government then offers what we call an investment tax credit, which is basically giving you a grant of about 50% on the capital cost of building, let's say, a carbon capture infrastructure. So that's a portion of what 45Q would give you in the United States, but that at least takes care of the capital stack and how do you minimize having to put equity into these projects. On the revenue side of it, they have an approach of, because of the carbon tax, if you want to avoid paying the tax, you can put a carbon capture plant, for example, and then if the cost of doing it is cheaper than the tax, then you have a reason to do these things. So in the case of the Canadian government, because of the uncertainty of government from one election to the other, they've decided to offer a contract for difference. So a contract for difference is basically a guarantee from the government that over the lifetime, let's say 15 years long term, the difference between the tax on the price on carbon and whatever you used as a guarantee price that they give you will be fixed. So that allows you to basically do the proper return on investment that you need. The Canadian government is going further with this, and they say, well, let's even buy some of the credit or offtake. And so they're offering basically to buy these carbon credits and keep it, because they think now that the price of capturing it is probably cheaper on the low-hanging fruit, and then they will be able to resell these credits down the road when everybody's going to be rushing and trying to get their carbon intensity lower. So those are different mechanisms. In order to protect from one country to the other to implement these things, you need what we call a carbon border adjustment mechanism, which is sort of people look at what product you import in the country, and if your carbon intensity is managed through these programs internally, and then the product, let's say steel coming in, has a high intensity of carbon coming from a different country that doesn't have this mechanism, then there's a tax being put at the country level to minimize the effect. So I think this is eventually a more sustainable way of doing this, but it takes more work for us to get these first projects going, because you need to stack the revenue and then the capital to be able to get this project going. It's much easier in the United States because everything is wrapped into the 45Q, $85 per ton.
And it's a bit of a sidestep, but since you mentioned carbon credits, does Svante generate credits actually from its removal?
We don't necessarily generate credit, but we participate in providing a technology for who owns the carbon capture plant would own basically the credits. And it's a negotiation between the emitter and we'll be storing the CO2, but typically the person or the entity that builds the carbon capture plant would have access to these credits. And then they would monetize it for the project. There's another market that's developing, which has been spurred by the carbon removal market, which is basically managing the carbon that's basically what we call above the ground, that's already in the atmosphere. And that voluntary carbon market is basically generating offtake contract at a price point much higher. Today, for low volume, you could get between $200 and $800 per ton for that CO2. At very large volume, I think you'll be more in the range of $200 to $300 per ton. But that voluntary market allows basically to stack some of these tax credits, for example, for the direct air capture or carbon removal projects from pulp and paper, for example, to get access to additional credits or uptake contract from consumer-based companies like Microsoft, Amazon, or even some investment bankers.
So with all of the above said, could you perhaps paint us a picture of how you see both carbon capture and carbon removal developing in the years to come?
We need to get to people talk about net zero. I tend to look at it in a more, that's not 2050. So I'm trying to look at it more in terms of a shorter vision. So if we can bend the curve of CO2 going out in the atmosphere, and we can start bending the curve toward lower, I think that's a goal. And that goal needs to happen by 2030. So this is just around the corner. So it would require at least 1 gigaton. 1 gigaton is 1,000 plant of 1 million ton. That's a big task, nevertheless, but probably one more practical and trying to shoot for the moon in 2050 with 40 gigaton. So I think it's going to be a mixture right now of doing it in the DAC demonstration market and then the industrial. So we're really trying hard. That's why we built a factory to make filters for enough to equip basically 10 plants a year. So by 2030, we could easily do somewhere around 70 to 100 plants of 1 million ton. And I think if we get to that level, that's I think we've achieved our goal of doing it and support the DAC market as well in getting it. It's all in the equation of finding the right pricing versus but most of the focus today in the industry about net zero and so far, all the narrative in my mind is around the energy transition. And we're trying here to change a bit the narrative by saying, yes, we need to do a green energy transition, but that's about making electrons. It's about making electricity. And AI and electrification of the transportation passenger car will create a much bigger demand on power. And yes, we need to have more renewable and the like, but that doesn't take care of all the goods and products that we make that have a carbon intensity. So the Carbon Smart is about, we call this the green industrial transition. So how do you make these products in the industry and manage the carbon that's emitted in making these products, which is all carbon-based. So I don't think anybody wants to get rid of the plastic or the polymer they use to make anything you see around the room and where you are. But we need to be smart of managing the CO2 that's coming out of these processes. So there's about 10 industrial sectors. And these sectors, pulp and paper is one, you see a chemical plant, another one, the steel plant, the cement plant, and so far. So once you know how to find a way of managing the emission of CO2 in each of these industrial sector, then it's a matter of deploying. So I don't know which one will come up faster than others. It all depends how you can monetize the CO2 in each of these industrial sector, but we're going after addressing each one of them. And our technology is quite versatile to be able to do both low concentration like air, all the way to industrial in all the sectors. So we're trying to demonstrate and get traction with these customers. There was less than 1,000 companies in the world, all that would eventually own these 10,000 plants. You take a big steel producer, you would have 30 steel factory around the world. So if you do one demonstration in one, eventually you can multiply this thing by 30, yes? So you do these things in all these 10 sectors, and that's how you come up with 10,000 plants.
Excellent. Claude, one final question for you before we wrap up this episode is circling back to Svante. What are the company's plans and upcoming developments for the near and maybe not so near future?
Well, the near end is we are finalizing the construction of our filter manufacturing plant. So we're spending $125 million US in that facility. So imagine 2 years ago, I had to go to my board and says, I'm going to build a factory to make filters, and I have no purchase order. So I needed some investors and board members that truly believe in the market. So that's one. The second is we have basically secured a commercial agreement with Climeworks to support them in the deployment of their DAC journey to 1 million ton plus facility. That will take up quite a bit of our capacity to make filters, probably, towards 2 or 3 years of capacity just to meet the 1 million ton demand that they have. So that's a good thing. We also were able in the industrial sector with one of our shareholder and partner, Delec, to get together a grant from the U.S. government of $95 million to do about a 50% cost share on a first refinery application with Delec in Texas. So, and we have a couple of other ones that we're trying to be quite active in the industrial sector. So we're starting now to ramp up the manufacturing, and then we have orders that are starting to appear. So quite exciting time.
Perfect. Looking forward to future announcements from the company. Claude, thank you so much for being here today. This was a hugely insightful conversation, and I appreciate every second of it.
Thank you. Remember, carbon smart.
If you enjoyed this episode of the Carbonsations podcast and would like to hear more conversations like this, please be sure to subscribe. We really appreciate the support.